the total horizontal component of electromagnetic field, which is derived in previous lecture, it is nothing but h of ht is equal to ha plus hb plus h of hc, and accordingly finally we will get the equation ia upon 2 pi y plus h upon x plus s square plus y plus h whole square minus y minus h upon this term. Similarly, the remaining respective current phases, right? So what we are going to do right now, we are going to calculate the magnitude of this h of ht and this h of vt, means magnitude of horizontal and vertical component. So just time being, I hope you have written it down in your notebook. If not, then also okay. Uh, I will continue the next part. Magnitude of h of ht and phi of vt. That is magnitude of horizontal and vertical component. What is h of ht? It is total horizontal component of electromagnetic field. So in above equation, what we did means there are some currents. See, in this equation there are three currents: IA, IB, IC. And if I'm going to write down the equation for IA, IB, IC, IA is equal to what? I at an angle of 0, right? IB is lagging to IA by 120 degree, and IC is leading to the IA by 120 degree. So accordingly, let us say these all phases are of having equal magnitude, right? The magnitude is denoted by I and having a phase difference of 120 degree. And this phase difference, it is with respect to each other. So let us write down the equation for this current. IA is equal to I at an angle of 0, right? So if I am going to write down in rectangular form, this can be also written as, means this at an angle of 0, it can also be written as I in bracket cos of 0 plus j sine of 0. Okay, and if I solve this, what is cos of 0? It is 1, and sine of 0, it is 0. So it is I in bracket 1 plus j0, right? Now the same way, what is IB? It is nothing but I at an angle of minus 120. That means it is lagging to the IA by 120 degree. So it can also be written as I in bracket cos of minus 120 plus j sine of minus 120 degree. So what is the value of cos of minus 120? It is minus 0.5 or minus half. So this is I in bracket minus 0.5 and minus j 0.866. You can find out by using calculator. And similarly, IC is equal to I at an angle of plus 120. That is, it is leading to the IA by 120 degree. So this is I in bracket cos of 120 plus j sine of 120 degree. Finally, it is I in bracket minus 0.5 plus j 0.866. Okay, so these are the three currents which are lagging, which is having equal in magnitude but phase difference of 120 degree. And what we will do, see, in this equation, this factor, let us say suppose this one, okay, so I will denote it as Ka, this one is as Kb, and this one is as Kc. So what will happen, this h of ht will be Ia upon 2 pi into Ka plus Ib upon 2 pi into Kb plus Ic upon 2 pi into Kc, and after that Ia I will replace by this. Ia is equal to this value, I in bracket 1 plus j 0. So let us say for horizontal component, what is k? K is equal to y plus h. Here, what is k? Y plus h upon this term minus y minus h upon this term. So let us write down. that is x plus s whole square plus y plus h bracket square minus y minus h divided by x plus s square plus y minus h square. What is kb? Y plus h divided by x square plus y plus h square minus y minus h divided by x square plus y minus h whole square, right? And similarly, what is kc? Y plus h divided by x minus s square plus minus y minus h divided by x minus s square plus y minus h square. So these are the values of Ka, Kv, Kc. Similarly, in case of horizontal component, I will denote it by let us say, see this. This one is, let us say, suppose Ja, Jb, this is Jc. So after replacing this value, what will be the HVT? HVT is equal to, that is vertical component of electromagnetic field. It is A upon 2 pi into Ja plus Ib upon 2 pi into Jb plus Ic upon 2 pi into Jc. Why we are going to do this? Because we have to find out the magnitude of HVT and H of St. So similarly, for vertical component, Ja is equal to x plus s upon x plus s square plus y minus h square minus x plus s divided by x plus s square plus y plus h square. Same way, what is JB? It is equal to x divided by x square, sorry, yes, x square plus y minus h square minus x divided by x square plus y plus h square. And similarly, JC is equal to x minus s upon x minus s square plus y minus h square minus x minus s upon. So these are the values of Ka, Kb, Kc and Ja, Jb, Jc. So if I'm going to consider this value, the horizontal component will be, that is the horizontal component of magnetic field. It can also be written as H of Ht is equal to Ia upon 2 pi into Ka, right, plus Ib upon 2 pi into Kb plus Ic upon 2 pi into Kc. So what is Ia? Ia can be written as, in terms of, see, Ia is equal to I in bracket 1 plus J0, because it is with angle 0 degree, right? So I will place the values. H of St is equal to I on 2 pi Ka into 1 plus J0, right? Plus I upon 2 pi Kb in bracket, it will be, you know the values, minus 0.5 minus 0.866 J and plus I upon 2 pi in bracket Kc into 0.5 minus 0.5 plus J 0.866. Okay, after that, what I will do, I will just take this I upon 2 pi common throughout the bracket. So what else? I upon 2 pi जर common घेतलं तर bracket मध्ये काय राहील? Say Ka into 1, it will be only Ka plus I have to multiply this term by Kb. So here it will become minus, right? Minus Kb into 0.5 minus J 0.866 into kV, right? So here it will be minus 0.5 kc plus J 0.866 kc. Now, see, if I'm going to consider this term and I'm going to take 0.5 minus 0.5 common in these two terms, so inside the bracket it will be kb plus kc. Same way in this term, if I'm going to take this plus j 0.866 common in bracket, there will be kc minus kb. So just write down the equation. This is I upon 2 pi a as it is minus 0.5 inside the bracket. What will happen in these two terms? It's kb plus kc, right? And I will take plus j 0.866 common from these two terms. In bracket, it will be kc minus kb. Okay, so this is nothing but value of h of st in terms of let us say complex form, right? But what I want to find out means, see, if we consider this equation, these are the real part and this one is a imaginary part, right? So if I want to find out the magnitude, you know that if there is a term x plus jy, what is the magnitude? It is under root x square plus y square. So same way, this one is real part and this one is imaginary part. So if I want to find out the magnitude, let us say the magnitude of h of st, it will be, let us say it is denoted by h of st, which is equal to, I will take I upon 2 pi common, and it is ka minus 0.5 kb plus kc bracket square plus, okay, so what is the square of j 0.866? You know that j square is equal to 1 and 0.866 it is equal to 0.75, so it is 0.75 in bracket kc minus kb whole square root, set the square root. And if I'm going to solve this equation, means I'm going to take the expansion of this term, finally I will get I upon 2 pi inside the bracket ka square plus kb square plus kc square minus ka kb minus kb kc minus kc ka square root. It is in ampere per meter. Okay, so same way, if I'm going to find out the magnitude of vertical component, similarly, so the value of that vertical component, I will just write down it directly. For time, after a particular time, you can solve it by yourself. It will be h of Vt, the magnitude of vertical component. It will be I upon 2 pi, same like this one, j square plus jb square plus jc square minus jb minus jb jc minus jc ja inside the square root. Is also in ampere per meter. So these are the magnitude of HVT and H of ST, that is a horizontal and vertical component. And if we consider these are the magnitude, the corresponding values of flux density. So what is flux density? B is equal to mu 0 H, right? So the corresponding, you know that B is equal to mu 0 H. So B of ST volume, it will be mu 0 into H of ST. In the same way, B of VT, that is value of flux density for vertical component, it is equal to mu 0 into H of Vt. and it is having unit Tesla. Okay, so this is all about equation for, or we can say horizontal and vertical component, magnitude of horizontal and vertical components.